Hi, everyone. I think I'm going to kick off now. Thanks very much for joining me. I'm going to be running through a presentation today about InfluxDB for industrial IoT, so specifically focusing on some of the challenges that we hear from our customers in the industrial IoT space when they're undergoing these use cases. I have these conversations every day. My name's Ben Corbett. We do have a stand by the main stage, and my role at Influx is a solutions engineer. So I basically work with customers for them to figure out if InfluxDB is going to be a good fit for their use case, and if it looks like it is, helping them to get the most out of it. I come from a background in mechanical engineering, and then slowly seeped into software and condition monitoring platforms. Been at Influx for about 4 years. So starting off right at the beginning, the obvious, the native language of your industrial equipment and sensors is time series data. Whether it's unique signals, different collection intervals, industrial tags, statuses, alarms, things like this, your assets are basically shouting at you. And there's often a rich, untapped history of the conversation that these assets are trying to have with you. Essentially, InfluxDB was natively developed to handle time series data. We define that as anything with a timestamp. So that can be all of those data sources that I've just mentioned there. And it's really important to distinguish that from different types of databases because we handle the data very differently. We collect it very differently, and we want to query it very differently, windowing, aggregates, things like this. So basically, giving people a platform to be able to build time series workloads in a way that's performant, easy to use and modern is why time series databases like InfluxDB existed. Built for SCADA, not for smart factories. So legacy solutions such as data historians are fantastic at historizing SCADA data, PLC signals, things like this. But they're not built for the demands of Industry 4.0. How could they be? They've been around for a very long time. In this new ecosystem, we have new personnel, new roles, new challenges, new tools, and of course, new opportunities. We always really encourage customers to focus on not just on basic monitoring and threshold checks, but go beyond that. Try and build a platform that allows your workforce to explore value and results-orientated use cases. Appreciate that's a bit fluffy, but what we like to say is maybe focus on reliability improvements, efficiency improvements, or added value. So for example, product quality is one that comes up a lot to improve customer satisfaction, or sometimes even completely new revenue streams. Time and time again, I chat to customers every day who are experiencing bottlenecks with using historic solutions to undergo this. Sometimes even blockers, not bottlenecks. And what we're trying to say is that customers that build the right foundation to explore these projects, they don't always work, as we all know, but to be able to implement and scale them beyond that are the ones that will be ahead, and those that don't have that correct foundation will be left behind. So here's some of the challenges just bucketed up into groups that I see that customers chat to us about, right? So I'll start off at the beginning. Scale, probably the most important one. So not only are we instrumenting every available data source, but we need the data in a higher fidelity, and we want to store it for longer. That is really important to avoid shallow reporting and have rich historical analysis. Basically scale. Customers really struggle with that scale topic there. Development blockers. A lot of these legacy tools baked into the OT domain and plant networks are very proprietary closed systems. And now come along your data scientists and data engineers that are used to working in open formats such as SQL, Parquet and things. And they basically really struggle to develop against it and extend it. So point number 2, it kind of slows customers down, development agility. Here's the issues they face. Data silos is a really big one that comes up all the time. So obviously this data originates in the plant domain, in the OT domain, where it is basically trapped in a silo or an island. And customers who have global plant networks, or sometimes even global devices, they have no centralized access capability. And this basically means your data scientists and data engineers have to go back into the plant network. We call that data cherry picking, which causes accessibility issues, bandwidth challenges, not to mention security issues. And of course, there's a huge duplication of effort associated with grabbing that data. So we need to avoid data silos. Last but not least, coming up all the time, limited context. So the ability to be able to contextualize those industrial signals. Batch ID, operator ID, area of the plant. This enriching your data with this additional context essentially gives you more clues to work with in reporting and analytics. So if you haven't got who I work for by now, it's InfluxDB. Yeah, we're a time series database, and we specialize in basically doing this, in storing data with a timestamp. So I'm going to even make this more specific to a SQL database instead of a general purpose database. So why not a SQL database for IoT workloads? I've kind of summarized it into 3 key areas, scale and speed being the first one. So we're collecting data at higher fidelities and things like this, and there is a transactional overhead associated with relational databases, basically. They're not designed for high throughput. Queries lock up, a storage gets very expensive. So anything works at low scale, but as you start to scale up, customers who use SQL will start to experience these symptoms. I've had probably one conversation every hour about this kind of stuff since I've been at this conference. Storage and cost. So relational databases store each row independently with minimal compression. Time series specific compression acknowledges that time series data is quite repetitive, right? We take the indexes out, voltages and temperatures over time. So through having those time series specific compression algorithms allows us to really limit the storage cost and reduce the compression. And as storage costs balloon in relational databases, obviously so do costs associated to that. And last and definitely not least are insights. So again, relational databases, great at basically selecting records. But time-based analysis uses windowing, moving averages, aggregate, downsampling, sometimes even retention policies to evict older data. And anyone that doesn't use a time series database has to build those workloads themselves, which can get quite complicated in terms of maintenance. So again, mapping these to kind of what Influx would bring to Industry 4.0, the capabilities, and I've tried to put some of my personal customers against these as well. So we spoke about massive scale. Time series databases in general, not just Influx, are eventually consistent, and they decouple ingestion from storage from query. So you can basically fine-tune and achieve very high throughput workloads. OneWeb, for example, has gigabytes a second, tens of millions of record a second coming in to underpin their satellite operations center. Efficient storage, so 2 aspects to this are time series specific compression and using Parquet files, but then also we're backed by object storage, so orders of magnitude cheaper than SSDs, basically. Really good for IoT workloads where that long historical analysis is essential to underpin ML models, basically. Cardinality, Heineken, everyone's favorite customer, meeting these guys later today. They augment their bottling and packaging industrial data from their global network of breweries with additional contextual information to improve reporting. Things like group by manufacturer ID, and they can have a look at different types of queries. Tesla, we underpin the app for Tesla's Powerwalls. So basically, even though we are eventually consistent, we allow you to query the data as soon as it has landed in a very performant way. We recognize that people think most recent data is the most useful, basically, for statuses and alarms. So we allow you to do that. Deployment flexibility, a really popular one for industrial IoT. So not only can we deploy in the cloud or on-prem in your own data center, but we can be deployed as a single node at the edge and provide durable data synchronization into a centralized instance. So this allows customers to have edge storage and a durable data transfer method out. So very useful for that kind of edge redundancy. And interoperability. We're obsessed with being open source. You won't get a vendor lock-in with Influx. So for example, Parquet files, SQL being the query language. This basically means your data engineers and data scientists don't have to worry about things being proprietary. Now they can use the tools that they like to integrate with the data really simply. I'll skip through this one quickly because I think I might be running out of time. But this is a bit of a bird's eye view of what a tech stack with Influx looks like. On the far left, you've got your data sources, and there will always be a middleware layer in between those data sources and Influx. 3 main methods to get the data in. 1, client libraries or just a manual API write. Customers can use our software development kits to basically create their own client and write the data in. Middleware. So for example, solutions like Kepware, HiveMQ, HiByte, Litmus all have built-in plugins for Influx. So if you use one of those to scrape industrial data, they can output it into Influx in an optimized way. And of course, Telegraph, that's a solution we developed. It's basically a plugin-driven data collection agent. Plugins for all of the major data sources, IoT ones just to call them out, MQTT, Modbus, Siemens F7, OPC UA, and it packages up and writes data in Influx. Again, open source, actually more popular than Influx. Of course, the Influx data layer, that provides the collection and storage. And then on the far right there, we've got visualizations, different tools, again, some down here that have native collections for Influx. But then visualizations, 99% of our customers stick a Grafana dashboard at least for alerting and visualization on top of Influx. Again, works with Influx very, very nicely. 3 customers, just to finish you off on. So again, we spoke a little bit about Heineken. So we underpin their, we're just coming up to 100 breweries, scaling to 160 breweries. And we do bottling and packaging, and we soon want to do brewing. And basically, we collect all of their operations data. And from switching to that centralized method, instead of having plant-based silos, they basically realized that some plants in different regions were massively inefficient compared to others. So through having it centrally accessible, they could roll out the benefit of how other plants are doing it to the ones that were slightly inefficient. This led to OEE, overall equipment effectiveness, improvements in $20 million annually, and we're still scaling. Volkswagen, one of my other customers, they basically had hungry data scientists and data engineers that wanted to run ML workloads on their historian, and they found they couldn't ingest the fidelity that they needed to run the models. So through switching into Influx, they could have 10x the granularity, basically, reduce the timestamp precision, which basically gave them more rich analytics. And last but not least, Siemens Energy. These guys are based in Trondheim in Norway, and they're building what they call the Rolls-Royce of battery stacks. Basically, we underpin their smart factory center for the manufacturing and assembly, but then also those battery stacks deployed in the maritime use cases. So they have like electrified ferries that go along the fjords, basically. And they can use that data to continually improve their processes. So again, all industrial IoT customers, and InfluxDB being kind of the backbone of their tech stack. I'm going to leave you on that. Thank you very much for your time. We do have a booth near the main theatre, so if you have any questions, come by and say hi. And yeah, just remember, built for SCADA, not for time series. That's Data Historian. Thanks very much.